A 10 kilogram mass hangs on a spring and is released from the ceiling, which is 10 centimeters high. The spring stretches to 0.5 to 2 meters. The spring constant is 5 newtons meters. What is the total potential energy? So first I started out by drawing a diagram which shows the ceiling and the original spring and the spring after the mass is hanging on it. We know this is 2 meters and we know this is 0.5 and the entire thing is 10 meters. But we need to find out the distance from here to the floor. So we just subtracted 2 from 10, which is 8 meters. So that is the diagram. And then we're going to start looking for the total potential energy, which we have 2 potential energies in this problem. It's going to be potential energy gravity and potential energy elastic. So the first we're going to find the potential energy of the gravity. So we're going to take potential energy formula, which is mass times gravity times height. So we're going to take 10, which is the mass, 10, which is the mass, 9.8 is the gravity, and 8 because we're trying to find the potential energy of gravity from the end of the mass to the ground. So that's 8 centimeters for the height, not 10, which gives us 784 joules. And then we're going to look for potential energy elastic. So in this problem, so in this formula, we have 1/2 kinetic x squared. Well, x is actually going to be, x stands for the new, which is this, the new height, the new pull down, times the natural, which is this. This is the natural because it's just hanging. But when the weight is added, that would be the new. So we take 2 meters, subtract 0.5, which gives us 1.5 meters. Which is what stands for x, and that's how we got that. So then we take, the constant is kinetic, so we have the constant of that is 5. So we take 1/2 divided by, times 5 times 1.5 squared, which gives us a potential energy elastic of 5.62 joules. And they want the total though. So we need to take them two and we're going to add them together and it gives us 789.62 joules.